Today on Under the Big Tree, 3D printing personal protective equipment for those in harm's way. Earlier today, I shot a quick video on creating an improvised vocal booth for voiceover people who were all of a sudden out of work because they couldn't go into recording studios anymore. And in passing, I mentioned my 3D printer, which was printing away PPE, or personal protective equipment. The comments that I got almost immediately were not as much about the vocal booth as about the 3D printing and about the personal protective equipment. People were impressed and they wanted to know more, and so I was going to make a big fancy video, but rather than doing that, I think I'm just going to take the time right now to tell you what I've been doing and why. We're in the middle of the coronavirus pandemic. I don't know about you, I'm not sleeping well. I'm constantly worried. I'm worried about my dad and my aunt who are in their 80s. I'm worried about me and my family getting sick. I'm worried about work. I'm worried about all of my friends who have been furloughed and who all of a sudden have had their paychecks dry up. I worry about the state of the world. I worry about education in the United States, where all of a sudden my kids have just lost half a year's worth of schooling. I worry about how we will ever create a sense of normalcy again, and what normal even means anymore after this. So I'm guessing if you're watching this that you're probably going through some variation of all of the same kinds of worries and misery that I am. So let me tell you what I have done to try to be able to help both myself and the world at large. So a few weeks ago I saw an article about a 3D company in Italy that had invented a piece to be able to allow Italian hospitals to be able to reuse the ventilator systems that they so desperately needed. And I immediately was taken by the story and followed it and researched it and took a look at how 3D printing might be able to help. It's up to the ingenuity of us, the people, to be able to see what we can do to be able to help. And so I began researching 3D printers. I'd never used one before. I knew about what they did, of course, but I'd never used one. And I started to take a look very seriously about how they work and whether I, just some guy, could sit here and start printing personal protective gear that could help protect our nurses and our doctors and our EMTs and our grocery store clerks and our bus drivers and everybody else who puts themselves on the line and into harm's way every single day to try to be able to help. So I looked around a number of different websites. I tried to figure out through the bewildering universe of all of the different 3D printers which one was the best one in terms of reliability and, was reasonably priced, but it would allow me to be able to do what I needed to do. So after a couple of false starts, I settled on the Prusa i3 MK3S printer. This is a printer that's made in Czechoslovakia, in the Czech Republic. They currently have a 4 to 5 week lead time on getting them, but they are cranking them out as fast as they can. And these printers are going out all over the world where people just like me, and hopefully just like you, are printing out stuff to be able to help other people. So I ordered the printer. I was able to get it from a resource here in LA. These normally come as a kit, but I was able to purchase it assembled so I could get started right away. Today is Sunday. I received it Saturday, 8 days ago. And I immediately tested it, calibrated it, got it working, and got it to work. And it's been running pretty much 24/7 ever since then. So the first thing that I did with it was print a number of these face shields. So these things are very, very simple. This is what you actually print on the printer, and it takes about an hour or so to print one of these. And then you take overhead projector transparencies and you punch holes in them, 6 holes across here, and I actually, where is it? Took a 3-hole punch and I kind of decimated it. I hacksawed into the sides of it, and then I put a little spacer right there to allow me to be able to use it to quickly punch the holes in the top of these things. Oops. So what you do is you punch 6 holes across the top of this transparency, and then you can attach it all the way across, and voila, you have yourself a face shield. Now, this isn't enough to protect you from the virus, but what I like about it is that if you're wearing a mask and then you're wearing a face shield on top of it, first of all, it protects your eyes. And second of all, any fluid gets onto the face shield itself rather than onto the mask. And so it seems like there's an extra layer of safety there. You could either throw away these transparencies, or you could take them home and clean them with bleach or hydrogen peroxide and be able to reuse this as best you can. So that's a pretty exciting thing. One of the things that I really love about 3D printing is that it is absolutely an open source, global community kind of thing. So I didn't invent that design. There was somebody in Sweden who invented that design, and then they worked on it and revised it and made a Swedish version and a European version and then a North American version that would work with our page sizes, with 8.5 by 11 and with the 3-hole punches that we have here in the States. So that was a wonderful thing. This got distributed all over the place, far and wide, and was only one of many different face shield designs and ideas that are out there. One of the things that's so cool about this is people get the design and then they can open it up in their 3D modeling software, and they can revise it and they can iterate it. And if there's a version of it that's better for whatever reason, it takes less time to print, it's stronger, it's safer, whatever that may be, that goes out onto the internet, and then eventually, if it gets enough traction, then that becomes the de facto standard version that people are using. And so that's pretty darn exciting. A perfect example of that is this. These here are ear savers. So if you think about a medical mask, they have a couple of loops on them that you would normally put around your ears and wear it all day long. Well, the doctors and nurses were in a tremendous amount of pain having that rubber band around their ears all day long. And so, are you ready for this? An enterprising Boy Scout designed this, printed it, put the model up on the internet, and people all over the world have been printing these to be able to give to doctors and nurses. So the idea is, instead of the loop going around your ear, you can take it and you put this around the back of your head, and then you attach the loop around whichever of these different nubbins here fits the size of your head. So it takes the pressure off of your ears, and it allows you to be able to take a one-size-fits-all mask and make it fit the size of your head a little bit better. So this is a wonderful idea here of community in action, and of somebody coming up with a good idea and the rest of the world immediately grabbing it and making sense of it. So the most exciting one that I've been building, and the one that has been taking my printer most of the time, is this. This is an N95 mask, a hard shell, completely reusable N95 mask that was designed by the University of Southern California. So the idea behind it is that you take these pieces, you attach that piece into the front, you put a piece of HEPA filter, which will keep any virus from being able to come through, across this little crosshair thing, and then you snap that in place back there, okay? Then you take regular old weather stripping that you can get from a Home Depot, I got mine from Amazon, and you glue it with contact cement all the way around the edge, because this hard surface is going to hurt your face, and it's not going to create an airtight seal. But if you do that and you glue it all the way around, then you can put it on your face, and the weather stripping will help you be able to create a seal. Then you can either use elastic, or in my case, I got the rubber strips that they use to be able to tie off your arm when they're drawing blood. It's called a phlebotomy tourniquet. And those things I found available on Amazon, and I ordered those, and those are going to be the elastic bands that you use to be able to attach this to your face. So this is something that has been designed by a hospital, has been vetted and tested by doctors, and it's those hospitals that are asking for us to be able to print as many of these as we possibly can. So I printed my first 6 of them and drove them down to USC last week. The doctor came out. It was a completely surreal experience. I'm sitting there in my car waiting with my Ziploc bag of 6 of these things with my name in it and what type of plastic I used to be able to model it and all of that kind of thing. And then this guy comes out and I handed it through the window to him, and then he went his way. We chit-chatted a little bit, and then he went his way and I went back. I have now created another 15 of these masks. Ta-da! Oops. And these are going to the hospital tomorrow. So what I've been doing, because it takes about 11 or 12 hours to print 3 of them, this is what I start the printer running on right before I go to bed. So then in the morning I get up, I do my thing, I start working, and then I'm able to come over here and be able to grab a few more of these masks, put them in the box, and then print. Lather, rinse, and repeat. And I've been doing this over and over and over again. And before you know it, you've got 15 masks. That's 15 people who may not have had appropriate protective equipment to be able to keep them from breathing in COVID-19 particles that now will. And so that's why I'm doing it. It makes me feel really good to know that there are people out there who I don't know and I'll never see, but hopefully I help them. These face shields, the first thing that I did with these, so those are for doctors and nurses. These face shields are for everybody. And the first thing that I did with them was I printed 5 of them, and I took them over to my local grocery store. And I walked in, and there was, a grocery clerk wearing some little makeshift bandana mask kind of thing. And I said, I made these for you. And I gave him 5 of them, and you should have seen the look on their faces. They were so grateful and so blown away. And I said, how many employees do you have here that deal with the public? And he went over and he got the information, and he came back and he said, we have 26 people here at this grocery store who deal with the public. And I said, fine, then wait and I will be back. And I went and I printed, it took me another couple of days, and I printed another 21 of them and brought them back and gave them to the people at that grocery store. So everybody at that store has a face shield and a little bit more protection, when considering the fact that their job, they are out in front of the public and dealing with the public every single day. This gives them a little bit more protection along those lines. As I was walking into my house holding some of these, a guy came walking down the street and he said, where did you get those? And I said, well, these are face shields that I'm 3D printing for those in harm's way. And he said, well, I have a company in which we are delivering food to senior citizens all over Los Angeles. Could I buy 5 of those from you for my people? And I said, absolutely not. But you can have 5 of them. And so as soon as I finished doing the run for the grocery store, I went and ran 5 of them for him. And it has been growing and growing, and more people are asking me for face shields. And so I am just more than delighted to be able to print them and try to give them to people. This is stuff you can't get in the stores. And so it becomes time for us to be able to build these things ourselves. This is what I really love about the community aspect of what's been happening with this incredible tragedy, with this incredible pandemic. It's that, we see the angels of our better nature. We see the people of the world coming out and trying to figure out not what can I do for myself, but what can I do for others? What can I do to help? And so this 3D printing thing is what I'm trying to do to help. And I hope that you can find some way that you can help other people, whether it's sewing masks or going all the way down the road and getting one of these things and learning how to use them, or, whatever way you can help lift the burden of those around you. That's a beautiful thing. So I I assume that most of you by now have turned this off because it's rather long-winded, but for those of you who are still interested, I'm actually going to get into how 3D printers work and what it is that I've learned about these over the last, now that I'm a world expert, having spent 10 days working with 3D printers. Let me tell you how they work. So, the way that a 3D printer works is you can imagine a regular printer that is depositing ink onto a piece of paper, right? But instead of ink, these things deposit this plastic filament here, and you can get it in all colors. There are a number of different types of plastic that are used. There's PLA and PETG, which are the two most common new ones. There's ABS, and there's a number of other ones as well. The idea is that you have this feeder of filament that is bringing the plastic down into this thing, which is called an extruder. And the idea is that it goes into this thing, and at the bottom of it is a hot nozzle. And that nozzle gets hot enough to be able to melt the plastic itself. So it melts the plastic, it pushes it through, and then it deposits it on this bed here, on this piece of sprung steel. And it does that according to whatever the 3D computer model is that you have instructed the system to be able to use. So with this Prusa, it uses an SD card. I take that SD card, I plug it into my laptop, I go up and find a model that I want to be able to print. Those models are usually .stl files. And then I download it onto my computer. At that point, it's not ready to actually plug into a printer. You have to put it into a piece of software called slicing software. And what slicing software does is it opens up this 3D model, and then it allows you to tweak all of the variables about how quickly do you want it to print? What resolution do you want it to print at? What type of plastic are you using to print it with? How do you want to reinforce the inside of it? Something called infill. How many layers of perimeters do you want to be able to have around it? All of these millions of different parameters that you can tweak, that you change depending upon what it is that you're doing. So if you were doing some nice high-resolution bust as an enjoyable thing for your desktop, then you would set it on high quality and you would let it go and you would let it run for a long time for it to be able to print this thing up. But for this, it's on draft quality because I'm not caring at all about what it looks like. I care about the fact that it's strong, and I care about the fact that I can print as many of them as I can, as quickly as I can, to be able to get them out to people. So you tweak all of those parameters within this slicing software, and then you hit an export button. And then that export button outputs something called G-code. And G-code is a 3D printer specific series of instructions that tells the printer exactly how to be able to make this thing. So right now, the G-code that my printer is running is the code to be able to make these 3D masks. And I have it all set up so that it can make 3D masks on the plate at the same time. And it takes, as I said, about 11 hours, but that's wonderful because I don't have to sit here and change it over and over and over again. It takes, it allows it to be able to do it. So you take this G-code and you put it on an SD card or whatever the format is that you communicate with your printer, you plug it in, and then there's some type of interface on the printer that allows you to be able to do things like print from a card. So that's what this thing has been doing over and over again. The way that these 3D printers work, at least this one, is that they have three axes, X, Y, and Z. The X-axis is this extruder moving back and forth this way. The Y-axis is the stepper motor actually moving the bed forward and backwards so that the extruder doesn't have to be able to move all over the place. And then finally, the Z motor is on this whole system here along with the extruder, and it allows it to be able to move up and down, which of course you need to do because as you print, it gets bigger and bigger and bigger, and so therefore the whole system needs to be able to raise all the way up to whatever the maximum capacity of your 3D printer is. So in this case, this thing has it has a rough capacity to be able to print things up to a volume of 200 millimeters by 200 millimeters by 200 millimeters, more or less, 200 by 210. But that's basically what it is. Over here, to be able to absolutely nerd out, I have a Raspberry Pi, which is a little computer running Linux, and that Raspberry Pi is running something called Octopi. So it's an operating system that is optimized to allow this Raspberry Pi to be able to communicate with the Prusa 3D printer. So by having that connected up to it with USB and then having it Wi-Fi out to my network while I'm inside my house, I can see what the status is of the printer. And so if there's a problem or if the print is done or anything like that, I can find out about it so I can come out and swap it. The OpticoPrint software that I'm using that's communicating with it then goes and talks to an app on my phone called Octopod, which then allows me to be able to get a notification when the print is 50% done, when the print is completed, so I can come out and be able to swap it out, all of that kind of thing. And to add an even higher level of nerdism to all of this, and this is completely unnecessary, but you know, in for a penny, in for a pound, this here is a camera. This is called a Raspacam. It was a $29 camera that's attached directly into the Raspberry Pi, and it allows me to be able to see what the printer is doing. So not only can I get information, notifications on how the print is doing, but if the lights are on in here, I can look on my phone and I can actually see the printer printing my model back and forth. For now it's useful because I can see if there's a problem, and the printer's gotten jammed up a couple of times, so you know, that's a really useful thing. I have ordered a second Prusa. I feel like I'm making enough of a contribution that it was worth it for me to be able to invest more money in getting a second printer. This first one I ordered assembled. The second one I ordered as a kit. It's much less expensive. As I said, it'll be here in about 4 weeks, but I'm pretty sure that we'll still need this kind of thing 4 weeks from now. And then I'll have the fun of assembling it as a kit. Now that I have one assembled version, I have something to be able to compare it against, to be able to see if I made any mistakes. But they have incredibly good instructions on how to be able to build it and test it and calibrate it and the whole thing. Oh, a couple of other things. Every time you finish a print, you need to clean the print surface, and I use isopropyl alcohol to be able to do that. I'm getting worried because I'm running out of it, and you know, as you know, getting things like alcohol are not very easy right now. So I will have to improvise something different when this is done, such as the way of time of the coronavirus. It has been incredibly reliable. It has been running consistently. It makes me feel good, and the look on the faces of the people that I have been able to give these things to be able to help them and to be able to help others is worth more than anything I could imagine. So that's about all I have to say. If you have any questions about all of this, please feel free to leave a comment in the comments below this video. Thank you for listening to me ramble on, and I wish you the best in navigating these incredibly difficult times.